On Monday, we started talking about organic chemistry, and we started talking about hydrocarbons, and we named a few of them. We did a couple of complex ones in class, so that hopefully the homework will be a little bit easier for you if you started on the homework. So we got through all the naming stuff, and we showed alkanes, and we said that they're the simplest of organic molecules, right? There's only carbon and hydrogen and single bonds. We did show a few halo alkanes with some halogens on them as well, and a few that are substituents or isomers, right? Anybody want to define that word isomer for me? You remember from Monday? Isomers have the same and different,
but different structures.
same molecular formula and different structures, right? Okay. So, and those are the simple molecules, right? Those are alkanes that can be, and all molecules can have isomers, okay? So always remember that. We're going to talk more about isomers today. We'll talk about a different type of isomer today. So let's talk a little bit about the chemistry of alkanes and the properties of alkanes. First, we'll talk about what kinds of alkanes we can find, okay? So the simplest alkanes are the short ones, right? From 1 to 4 carbons. And these alkanes are common in used as combustion fuels, right? So we harness the heat from them, and we use them for various things like cigarette lighters. The smokers in class, right? Bad people, y'all. Ones that are a little bit bigger than that, have 5 to 8 carbons, are highly volatile. The ones that are that short are gases at room temperature. That's why they're handy as used as fuel sources. Ones with 5 to 8 carbons tend to be liquids at room temperature, and they can also be used as fuels. Okay, so things like octane, when you go to the gas pump and you see the octane rating on the gas pump, you now know that that's an 8-member carbon chain, right? Some of these other ones like pentane and hexane are often used in the lab as solvents for non-polar things. So things that don't dissolve in water can dissolve in pentane and hexane. Longer ones with higher boiling points from 9 to 17 carbons are liquids at room temperature. They're not nearly as volatile. They still burn though, so things like diesel and jet fuel are made up of these much longer carbon chains, and there tend to be mixtures of these longer carbon chains. They're not all one specific carbon chain. Really long ones with 18 or more carbon atoms tend to be waxy substances at room temperature, things like Vaseline or petroleum jelly or any other waxes you know of. Anybody have any wax on them right now? Earwax. It's a wax, isn't it? Or why did they have that picture of apples up at the beginning of this section? Yeah, so anybody ever bought apples at the farmer's market? Yeah. Are they nice and shiny like that?
No.
No, because they don't spray wax all over them, right? Those ones that are, you buy at the grocery store, they got a little thin coating of wax on them so that makes them nice and shiny. Like you do on your car, right? You put wax on your car, make it shiny. That's what they do to those apples so they look appetizing. So now you know what you're eating about your food. It's kind of disgusting sounding, isn't it? Where are you going with that table there? You know that's my seat when you're not here. Alkanes are non-polar, meaning they do not dissolve in water. So they have a picture up here of an oil spill. This oil spill was in the Gulf of Mexico. They're non-soluble in water. They tend to be less dense than water, which means they float on water, and they're all flammable. So, does anybody know what the ultimate fate? At the end of the other class, I didn't understand what I said. What happens to most of the oil in an oil spill? Anybody know? What happens to it? It does not sink to the bottom. Where does it go? It does not just sit on the surface. Where does it go? You got one other choice left. Sinks, floats, or evaporates. Most organic alkanes are highly volatile, right? The short ones are gases at room temperature. Bigger ones tend to be very volatile. Like gasoline is volatile. What does that mean, volatile? means it evaporates, right? Okay, most oil actually evaporates. The stuff that we collect with booms and absorbents and all that stuff, that's a small percentage. A chunk that settles to the bottom or gets on the birds and all that kind of stuff, that's a small part too. But we notice that because it has a big impact in the environment, right? So the biggest part of the oil spill actually goes out into the atmosphere. It actually just evaporates, right? It's like if you leave gasoline sitting out. So, alkanes with strong carbon-to-carbon bonds react with oxygen in the atmosphere via combustion, right? Most alkanes are combustible. Waxes are combustible, right? You burn wax when you burn a candle, true?
Yes.
Okay, that's a long chain alkane. And you generate CO2 and water. This next section is going to go through, this is really the only reaction of alkanes. We're not going to dwell on this because you guys should already be able to balance this equation. You guys should be able to balance alkane combustion equations. We did them a long time ago. So since we did it before, we're not going to practice balancing them. How's that? You guys should be able to do these. Now, the next class of organic molecules, the next most complicated ones, are alkenes and alkynes. They differ from alkanes in that they now have instead of having all single bonds for carbon to carbon, they can have double and even triple bonds for carbon to carbon bonds, okay? So let's talk about alkenes and alkynes. Alkenes contain double bonds. What does it mean, double bond? It means that two carbon atoms share 4 electrons instead of 2 electrons. Okay? With a triple bond, an alkyne, they share 6 electrons. Okay? So double bond shares 4 electrons, triple bond shares 6, alkenes, alkynes. All right? Make sense? Okay. These guys can react with hydrogen gas to produce a hydrogenated alkane. Okay? So, all these hydrocarbons that have double and triple bonds are unsaturated. Unsaturated means that it contains less than the maximal amount of hydrogens. Those hydrogens have been replaced with a double or triple bond. Okay? Anybody ever heard of polyunsaturated fatty acids? Yes. Or fats, right? That means that it has lots of double bonds. Okay? Does that make sense? Yes? Sort of? Okay. So when you hear that word unsaturated, it means it has double and triple bonds. We're going to talk about adding hydrogen to these bonds in a minute. So, alkenes contain 1 or more carbon-to-carbon double bonds. Alkenes mean double bonds. Here's the simplest possible alkene. This is ethene. If it was an alkane, the name would be what? Ethane. See the difference in the ending here? The ending ene tells me that what? This is an alkene. It has a double bond. As opposed to ethane, which would be a single bond. Okay? Everybody sees that? We're happy with that. Not going to worry about the shape. One common use for ethene is it's used as a ripening agent. They take these big, huge warehouses and they flood them with ethene and it triggers the fruit to start ripening. Because they pick fruit where, like South America, they bring it to the U.S., they expose it to ethene, then it starts to ripen. They pick it when it's not ripe, right? Okay. Alkynes contain triple bonds. This particular one is called acetylene, right? That's a common name for it. The correct name for it would be ethyne. See the ending now? It's an alkyne because it has a triple bond and the ending is YNE instead of ANE or ENE, right? See how the ending changes when you go from single to double to triple bond? All right, so you should be able to recognize that. So, look at both of these, and I want you to tell me, is it an alkene or an alkyne? The top one is an what is the top one? It's an alkene, right? There's a double bond in the middle of it right there. What about B? It's an alkyne. YNE, right? There's a triple bond.